Let's look at this simple code again. We have this text, hello world, and a frame around it with a width 300, height 100. Now, like I said, despite attaching this frame modifier here, no amount of futzing from us can ever force this text view to extend its bounds beyond the natural width and height of its lines. That's just not how SwiftUI works. Of course, the real question here is, well, what is the natural size for this text? And the answer is that text likes to live on one long line. And that's exactly what it will do unless we ask it to do something else. For example, we might say our frame modifier has a width of only 30 rather than 100, and you can see straight away it now wraps across multiple lines. There's no longer enough space for the text to be on one line, so it's forced to wrap. And on the surface, this sounds like it might break the second rule of SwiftUI's layout system. The child chooses his own size, and the parent must respect that choice. In this case, the child is the text view here, and this frame view is the parent. And so how come the text is being forced to accept the size of its parent, which is the frame? What's really happening here is that all views use 6 different values to decide how much space they want to use for layouts. Understanding how these 6 interact is really the key to getting the most out of SwiftUI's layout system. The 6 are minimum width and minimum height. They store the least space this view will accept. Anything lower than these values will be ignored, causing the text to sort of leak out of the space that is proposed to it. Then we have maximum width and maximum height, which store the most space this view will accept. Anything greater than these values will be ignored, so the parent must position the child somehow in the remaining space available. Then we have ideal width and ideal height, which store the preferred space this view wants. Now, it's okay to provide values outside of those, as long as they still lie in the range of minimum and maximum. If you're coming from a UIKit background, think of the ideal values as being the intrinsic content size of your view. Now, it's the last set there, the ideal sizes, that store the natural size for our text. It's got an ideal width and height suitable to store all its characters on a single line. But it has no minimum size. It doesn't care if we try and squeeze the text down to a tiny little limited width here, it'll just wrap its text again and again and again. This is where the fixed size modifier comes in, which has the job of promoting a view's ideal size up to be its minimum and maximum size. And it's used like this. We can say fixed size. When that code runs, our text will appear at its original size, despite us attempting to override it with a frame modifier. Now take a moment to think about it. What do you think is actually happening with this code? Now, I know it's really tempting to treat that like a rhetorical question while I'll just answer it straight for you and you can move on. But what I'd like you to do is pause the video because you will have time to think about it, decide your answer to the question, what's actually happening in the code here, and you will learn more than me just telling you the answer. Even if you end up being wrong, at least you had a go at thinking about it. And that's the main thing. And remember here, in this case, you want to think about how will SwiftUI interpret this code and in what order. And this fixed size modifier, remember, has a job of making a parent view around the text, which will promote ideal up to be minimum maximum. And then, of course, the frame goes around the fixed size. Pause the video, have a think what it does, and then unpause. I can wait. I'm going nowhere. I'll be here. I can feed my dogs. You paused it? I'm trusting you here, yeah? Yeah, okay. Deal. Okay, what we end up with is this. We now have 3 views in total. We have this text plus a modified content plus another modified content. In terms of parent-child relationships, what's happening here is that our frame is the overall parent, which in turn has this fixed size view for its child and a text view for its child. When we make this 30 by 100 frame here at the end, it will offer that full space to this fixed size modified content child. And the view made through fixed size proposes that same size to its text view. And this text view has no idea it'll be placed inside a 30 by 100 frame. So it'll say, well, my ideal size is about 100 or 95-ish by 20, right? That's what I want for my text here. But I'm happy to take up less space if needed. And this fixed size modifier then uses that same information. So now it turns the ideal size, preferred, the requested size, into a fixed size. It's effectively doing this kind of code, frame width, text.ideal width, height, text.ideal height. It's not, obviously that code will actually work, but that's what it's doing behind the scenes here, right? It's forcing that size in place. And so now the frame will be told it has to position a child much bigger than a size it proposed. And it does so. It has not got a choice. That's how it works here. And so fixed size is how you promote this fixed size up to be, ideal size up to be a fixed size, an exact size. And you can use fixed size no parameters if you want to, or provide Boolean parameters to control one or either axis. In the case of text views, remember that fixing its horizontal size will mean go over one line no matter how long you are, which is basically the default. It's what text likes to do, right? If that's what you want, great. If not, you might find that fixing only the vertical size is more useful. It allows the text to be squashed horizontally while still growing as tall as needed to be for its content, to handle line wrapping, of course. But what will other kinds of view do? For example, what if I'd said, let's do image Singapore, and then frame width 300, height 100. Now, on its surface, that's going to make a 300 by 100 picture of Singapore Changi Airport. But any SwiftUI veteran will go, yeah, I can see that result. I know why it's doing that. It will know it won't work correctly. The image will be its original size despite the frame around it. It'll happily overflow the frame. If you're using Xcode's preview canvas, just switch off from this live preview here, the interactive preview, and switch to over selection mode like this one here. And let you select the various parts of it. You can see our frame there, maybe looking through this little blue line. That's the actual outline of our frame right there. And if you aren't using that, if you're using the live view instead, you can see what it's doing by just saying .clipped. Don't let your content escape like that. Now it's clipped inside that frame we made. And perhaps now you've got a better idea of why it's doing this. Image views get their ideal width and height directly from the image data that we loaded it from. The pixels from the Singapore picture here. And just like text views, no amount of futzing from us can ever override that default size. But Paul, I hear you say, surely we can override the default size, making it resizable. No. Again, no amount of futzing from us can override the ideal size of an image. Yeah, we could say, let's get rid of clipped. Let's say, yeah, okay, you be resizable. You go for it. You resize. Oh, look, I've overridden the size. But you haven't. If you just say .fixed size afterwards, bang, it's back to its full size again. It makes the image resizable, but then promotes the ideal size back to be a fixed size. And lo and behold, it's back to its original size again. Now, earlier I said when we use any modifier, we are most of the time making a new view that wraps an original view to add some extra behavior or styling, and resizable is one of those modifiers that does not create a view. It sends back the original image with the resizing behavior in place, but that's not wrapped in some kind of resizable modified content. All we did is tell that original image to have a flexible width and height, but the underlying size, the underlying ideal data is still there. Now the key here is to remember that whatever frame you try to apply to the image will automatically inherit values from the image that you don't specifically override. You'll get them. For example, a very common problem with SwiftUI learners face is when you use a very long image, very wide image alongside some text like this, the VStack alignment of leading here with image of wide image like that. And then text, hello world. This is a layout test. And you can see my image is too wide for the thing, and so my text is kind of hanging off the end here. We're just sort of seeing the end of this, and then it is a layout test. So basically all this text here is missing. because the whole picture is so wide, it pushes the whole thing off the edge of the screen here, and that means the VStack goes beyond the edge of the screen, the text on the edge of the screen. It's rarely what you want. So how do you go about fixing this? And to do this without squashing the image, the simplest thing to do is wrap this image in a frame with a completely flexible width. I can say image, wide image, and then frame min width is 0, max width is .infinity. And now you'll see the full text appears below. Now, critically, if you remove min width 0, boom, back to our old problem. You've got to have that min width 0 in there because it will now get, without that in place, take it away, it'll now get the minimum width from the image. And again, the minimum width by default will say, please show the entire picture, my natural size. And even with min width and max width in place, if we still added fixed size afterwards, it'll still break. We're promoting that ideal size back up to being a full-on fixed size. It shows the ideal width and height is still there. We don't get rid of it. Another common problem that beginners face is when we want to have two views, the same width or height, depending on their content. For example, a layout like this, HStack here with text of forecast, and then some padding, and then background of yellow, and then a text of the rain in Spain falls mainly on the Spaniards, and then padding with background of cyan. Like that. Now, when this preview reloads, all being well in a minute now, please. Come on, preview, you can do it. There we go. You can see the different sizes, right? The forecast and the text to the right are different heights, which isn't ideal, and often you want to be the same height. What's happening here is in this layout, the HStack proposes the available space to its children, to this text and thing here. And they'll then say, well, okay, you've let H1, it'll then split the space up based on what they send back. And in practice, this larger text you'll need significantly more space than a smaller one, and when space restricted, it will wrap. How do we make these two the same size? Well, work backwards, right? The background modifiers here will create frames based on data they receive from the text they wrap. So the background will say to the padding, background will talk to the text, But if we then add a custom frame around our text, then we're saying actually you can grow or shrink freely in terms of height. So I might say that my text here has a frame max height of infinity, and it'll grow to fill the screen. And the same over here for the second text, and it'll grow to fill the screen, which is fine. But yeah, we've told this background you now have a flexible maximum height, so grow upwards as much as you need. We haven't change the ideal height. That still comes through from the text of A and B, the text and the forecast here, and the HStack will calculate its own ideal height to be the maximum of the ideal heights of the two views it contains. So I'll position this one, and this one's bigger, that'll be used for the HStack. So it uses the larger of the two. And our two text views have infinite maximum height, and they'll therefore expand to fill all the available space. The HStack will also expand to fill all available height. That's just how it works. But if we say to the HStack, actually, I want you to have a fixed size, like this, I'll do fixed size, horizontal, false, vertical, true, bang, that happens. We get to make our two views have the same height with very little code. The HStack has a flexible maximum height to fill the screen, but still knows the ideal height, which is the maximum ideal height of its two views. So now I'm saying fix to that. Don't let them grow infinitely. Now telling the HStack to fix its size is different from telling each of their text views to fix their size. We want them to resize upwards to some limit, which in this case is the ideal size of their container. Now in the documentation for fixed size, if you look at it, in Xcode, I'll do that for a second, you'll see why. This is the documentation for fixed size. They try and explain what it does, and their definition of it is You can think of fixed size as the creation of a counter-proposal to the view size proposed to a view by its parent, which I think is quite apt once you understand what's happening internally.